Hi, welcome to another session of Circuits and Networks. In today's class 7 under two-port networks, we are going to see the impedance parameters in terms of other parameters, that is Y parameters, ABCD parameters and H parameters. How to obtain one parameter in terms of other parameters, that is the importance of this class. So let us begin with impedance parameters in terms of admittance parameters. For that, we have to concentrate first on impedance parameters. They are given by V1 and V2, which is equal to Z11I1 plus Z12I2. V2 is equal to Z21I1 plus Z22I2. And we have admittance parameters. Since we require Z parameters in terms of Y parameters, that is why I have taken admittance parameters also over here. So I1 is equal to Y11V1 plus Y12V2. I2 is equal to Y21V1 plus Y22V2. So let me take these equations as 1 and 2 and these two equations as 3 and 4. So let us begin with the actual solution. By Cramer's method, applying to equation 1 and 2, I can get V1 is equal to, that is the parameter, unknown parameter V1 is equal to, by Cramer's rule I am taking the value I1, I2 on the numerator and Y12 and Y22 on the numerator. In this way, the determinant value is taken like this, divided by the determinant of admittance parameters, that is Y11, Y12, Y21 and Y22. So with this I am going to get the value of V1, which will be equivalent to Y22 I1, that is the cross multiplication of this, minus Y12 I2 in the numerator part. In the denominator part, I'm going to get the determinant value, which is y11, y22 minus y12, y21, which will be giving you the value of v1, which is equivalent to y22 by delta y I1 minus y12 by delta y I2. Now this you can see I have obtained v1 in terms of I1 and I2. So I'm going to compare this value with equation 3, that is Z11I1 plus Z12I2. With this equation 3 and this equation of V1, I am going to get Z11 equivalent to Y22 by delta Y and Y12 is equal to minus Y12 by delta Y. So this is how we obtain the impedance parameters in terms of admittance parameters for V1. Now from the same Cramer's rule, I can get the value of V2, that is the determinant of Y11, Y21. I'm taking on the RHS of this equation as I1 and I2. I'm taking the unknown parameters over here by the determinant value of Y, which will be giving you the value as Y11 I2 minus Y21 I1. Just cross multiply on the numerator and denominator. I am going to get V2 in terms of I2 and I1, and this I'm going to compare with standard at impedance parameters, that is V2 is equal to Z21 I1 and Z22 I2, so that I'm going to get the value of Z22, which is equivalent to Y11 by delta Y, and Z21 is equal to minus Y21 by delta Y. Now with this analysis, I'm going to get Z parameters, that is Z11, Z12, Z21 and Z22 in terms of admittance parameters, that is Y22 by delta Y minus Y12 by delta Y minus y21 by delta y as well as y11 by delta y. In fact, I can write delta y outside. So 1 by delta y is equal to y22 minus y12 minus y21 and y11. So the admittance parameters are framed in terms of z parameters. In fact, z parameters can be obtained in terms of y parameters in this fashion. So I hope you understood this derivation. Let us go with the another approach, that is Z parameters in terms of ABCD parameters. For that, first take the Z parameters. You can see here I have taken this equation as 3 and 4. That is the same equation what we have done with the Y parameters. So equation 3 and 4 already are framed, and the the ABCD parameters, that is given by V1 and I1, that is the input voltage, input current in terms of output voltage and output current. I'm taking those equations as equation 5 and 6, and let us go with the actual derivation in order to obtain impedance parameters in terms of transmission line parameters. So I'm going to rewrite the equation 6 So I take equation 6, I'm going to rewrite. How I'm going to rewrite? See, I have taken here V2 equal into I1 divided by C. This is minus over here, which goes to the LHS side, it goes and becomes D by C I2. So just equation 6 is equation made equal into equation 7 and compared with the equation 4. The equation 4 is given by V2 is equal to Z21 I1 plus Z22 I2. So with this similarities, I'm going to get the value of Z21 is equal to 1 by C and Z22 is equal to D by C, and I'm treating this equation as 8. I hope you understood how I have reframed the equation. Now just substitute equation 7 in equation 5. Just we have changed the equation of 6 to equation 7, and that 7 I'm going to place in equation 5. So I'm going to get V1 is equal to AV2. So V2 value is 1 by CI1 plus D by CI2. That is what it is done over here. Minus BI2 as it is. Now this can be further simplified. That is V1 is simplified, which is equivalent to A by C I1 plus AD minus BC by C I2. So that I can compare it with V1, that is the equation 3, which is equal to Z11 I1 plus Z12 I2. With that I can get the value of Z11, which is equivalent to A by C, and Z12 is equal to AD minus BC by C. So that the impedance parameters in terms of admittance parameters can be obtained as 1 by C, A, AD minus BC, 1 and D. Is it that simple? Yes, it is. Now let us go with the next approach, that is the impedance parameters in terms of hybrid parameters. So I already have this impedance parameters as equation 3 and 4, and the hybrid parameters I'm framing the equations as equation 9 and 10, and the same technique I'm going to involve the technique which is done with the ABCD parameters. So rewriting this equation 10 in terms of V2, I'm going to get minus H21 by H22 I1 plus 1 by H22 I2. So equation 11 is framed. With this, I'm going to get Z21 is equal to minus H21 by H22. Just I'm comparing this with equation 4, and that is how I'm going to get the value of Z21. Likewise, Z22 is equal to 1 by H22. So let me frame this equation as 12 and substitute equation 11 in equation 9, so that I'm going to get the value of V1, which is equal to H11 I1 plus H12. This V2 is replaced with the help of equation 11, and that is being simplified like this, and I'm going to obtain V1 is equal to delta H by H22 I1 plus H12 by H22 I2, which give you the value of Z11. By comparing it to equation 3, I'm going to get delta H by H22 for Z11, and for Z12 it is equivalent to H12 by H22. After framing this equation 13, I can get the value of Z parameters in terms of hybrid parameters by this equation, that is 1 by H22 multiplied with delta H, H12 minus H21 and 1. So you have seen that we have derived all the other parameters in Z parameters. So Z parameters in terms of other parameters are obtained, and vice versa is also framed, like Z equal to the impedance parameters given by these four values. In terms of Y parameters, it is obtained like this equation. In terms of ABCDs, it is obtained like this equation. And in terms of H parameters, it is obtained like this equation. Fine. Now, compared to this result analysis, I can easily get the parameters, that is admittance parameters, transmission line parameters, and H parameters in terms of impedance parameters by equating the like terms and unlike terms. So what we have done here, you can see I have taken first Y parameters. So compare this Y parameters with Z parameters. You have Z replaced by Y. This delta Y is replaced by delta Z. Y22, Z22, minus Y12, minus Z12, minus Y21, minus Z21, Y11, Z11. Isn't that simple? So I have obtained impedance parameters in terms of admittance parameters as well as admittance parameters in terms of impedance parameters by the simple comparison. I hope you have understood how we have framed these two relations. Now compare the impedance parameters in terms of transmission line parameters and try to reframe the transmission line parameters in terms of impedance parameters. Here you have C. C can be equivalent to Z21. E can be equivalent to Z11. D can be equivalent to Z22. And you have AD minus BC, which is nothing but the determinant of impedance parameters. Here you have one. Replace the one same as it is in the transmission line parameters. So you can see ABCD is equal to 1 by C, that is 1 by Z21, Z11, delta Z, 1, Z22. I hope you understood how I framed this particular equation from this present equation. Now set the same example for hybrid parameters. You can see here 1 divided by H22, it is here Z22. So I can take this H22 will be equivalent to Z22, delta H will be equivalent to delta Z, H12 will be equivalent to Z12, minus H21 will be equivalent to minus Z21, 1 will be remain as it is, so that I can obtain hybrid parameters in terms of impedance parameters. So that is the beauty of the subject. Now once you have obtained impedance parameters, you can convert these impedance parameters to any other parameters with the help of these conversion. So please remember this derivation and remember this technique so that you can find easy way to sort out any complex problem in short time pertaining to the problems involved with two-port networks. I hope you understood this particular class. Please like and share among your friends about this particular session and subscribe to the channel, and please press the bell icon for the